Welcome, everybody. We are going to deliver a webinar on delivering production ClickHouse apps on the Altinity Kubernetes Operator. I hope the whole webinar will go better than that first line, but welcome again, and thank you so much for joining us today. I'm going to be working with my colleague, Alexander Zaitsev, who is the Altinity CTO. I am Robert Hodges, the Altinity CEO. Before we start this webinar, I'd just like to kick off with a couple of housekeeping items so that you won't have to take frantic notes. The first thing is that this webinar is being recorded right now. We will send you a copy of this, of the recording, or a link to it, along with a link to the slides right after the webinar finishes. So you'll get it sometime later today. So no need to, you can just sit back and listen. It'll all, as long as you've signed up, you'll get the information forwarded to your email. The second thing is we do have time for questions, and in fact, we encourage them. You can enter them in the Q&A box. If we can, we will answer them as we go along. Since there are two of us, we may be able to answer them in background or just answer them as part of the presentation. We do have a lot to cover, though, so we'll probably reserve some of the questions for the end of the presentation. Finally, there's also a chat here. Some people like to put questions there. It doesn't matter to us. Stick them anywhere type them in anywhere that you want, and we'll answer them. So with that, let's dive in. Just a couple of a little bit of background information on Altinity. We are a vendor for ClickHouse, the best analytic database on the planet. We've been around since 2017, and we have a lot of experience running ClickHouse on Kubernetes. So we run Altinity.cloud, which has been up and running since 2020. Runs on, at this point, we have customers running on at least 4, maybe 5 cloud platforms. Actually, it is 5. Alexander probably has the exact number. We also support, we have a big support business, and we support a lot of people who run on Kubernetes as well. And in fact, that this relationship to Kubernetes, which started back relatively early on, we began to get into Kubernetes in a big way starting at the end of 2018, led us to write the Altinity Kubernetes Operator, which was first released in early 2020 and has been the foundation of many customer deployments, as well as our own Altinity.cloud since that time. So this talk is going to introduce you to the operator and also show you some of the features that enable you not just to do development, but also to build full-scale data platforms, in some cases consisting of hundreds of nodes. So with that, we'd like to do a quick introduction and demo that shows you how this works. And for that, I'm going to turn this over to my colleague, Alexander Zaitsev. So Alexander, I'm going to stop my share and let you take control.
So we start with the Minikube deployment that I have on my laptop. The beauty of Kubernetes and Operator is that you can try production configurations on your laptop before deploying them to the real production. And let me create a namespace first. This is a test namespace, and then deploy ClickHouse Operator using the simple deployment mechanism, the simplest deployment mechanism. So we see a lot of resources have been created. We will probably discuss them in a bit later. Let me double check that operator is up and running. Here it is. Good. And now we can go to ClickHouse itself. I have pre-created a simple manifest that contains ClickHouse Keeper installation. You can see it here. And ClickHouse installation. So we create 2 resources. ClickHouse installation, in turn, is referring to ClickHouse Keeper. You can see it in the Keeper section. There is a host Keeper myJK, which is a service name for ClickHouse Keeper. So let's create them, those resources. I just run kubectl create in test namespace. We can see that 2 resources were created and can track the progress now. So operator in the background, it reads those resources and reads definitions of how many shards and replicas needs to be created, what needs to be running and stuff. So you can see that it started to start first ClickHouse pod, and now you can see it starts in CHK, which is ClickHouse Keeper, the second ClickHouse pod, so it's all more or less in parallel. And here is when we have everything running. Let's double check. No, it's still one is still pending. Maybe it will. Now it's running. Okay. So all cluster is in place. We can also check this. It is still in progress because it is finishing the process. But we can already connect to ClickHouse, and we can do it using kubectl exec. I'm now in ClickHouse pod in one of the replicas. I haven't mentioned, but we started a replicated cluster. This is why we have a keeper. We can now create a table, and I will use a table with a schema from S3 bucket. We have some Parquet data. So it is now connecting to S3 in order to create a schema, get the schema. And you can see that schema has been created on 2 nodes. It is still an empty table, and I can immediately load a small portion of the data. I could read maybe all this data set, but I will just read 100 rows to make it faster, because the object storage is somewhere far away from this Minikube installation, and network is not great. It takes a little bit of time because ClickHouse still has to read quite a big chunk of Parquet and parse it, and only after that, so you see it reads quite a few rows, and we can check if we have everything here. I will check one row just to show you. Yeah, it is. We have data in our ClickHouse deployed by Kubernetes operator. Exactly one row, or 100 rows. And those rows are on 2 nodes because we have replication. This is as simple as it. It took me 3 minutes to spin up a cluster in operator with replication. If you have the bare bones ClickHouse, it will take you quite a lot of time to figure out how to configure it properly. Now we can go back to presentation. So let's see what actually ClickHouse and Kubernetes is. So maybe, Robert, you can start from here.
Great. And Alexander, let me suggest the following. Since I'm going for a little stretch here, you can go ahead and see if you can get your demo adjusted so that we can get it, because it is a good background for understanding what this does. Okay, so let's go ahead and look at the architecture of ClickHouse, because we're going to represent this in Kubernetes. So in the examples that we're using here, we have ClickHouse, which is which is as everybody knows, or most people on this call know, is an analytics server, has a shared nothing architecture, attached storage connected by a network. So here's an example where we have 2 servers which are replicas of each, set up as replicas, and we have a ClickHouse keeper, which is used to maintain consensus between those replicas so that they can figure out which one has which parts, get notified when new parts arrive, things like that. So Alexander, go ahead to the next slide. Okay, so what we're going to do is we're going to use an operator, which is the whole point of this talk, to control these clusters. And an operator is a special programming paradigm that is implemented by Kubernetes. And what it allows you to do is to create what are called custom resources. Resources are the way that we model distributed applications, I should say, container-based applications in Kubernetes. And what the operator does is it allows you to define any kind of resource, but equally important, it allows you to define the processing on that resource. And the way that it works, and this is just an example from the Altinity operator, is that you feed in this custom resource, and we'll show plenty of examples of this shortly, using kubectl. That's the standard command to send it to Kubernetes. Kubernetes reads it, looks up the resource type, and then it will go ahead and perform what's called reconciliation. It will look at the resource, and this has a definition of what you would like to have in Kubernetes to represent your ClickHouse server. And we will look at Kubernetes, see what resources are already allocated. Anything that's not there, we will create it and submit it to Kubernetes. So, for example, create pods and things like that. Anything that's different will be adjusted so that it matches the new version of the custom resource that you provided. This is a very powerful mechanism, and it's particularly good for databases because databases don't just have a layout, they also have complicated procedures to move between them. So here's an example of the installation that you can use to set up a demo. And we have two types of resources here. The first is a ClickHouse Keeper installation. So since Keeper is used to keep consensus, we want to get that up because when the ClickHouse servers arrive, they're going to need it. And you can see it's relatively simple. So there's really only one key thing here. It allocates a small amount of storage. It doesn't even say what pod it's using because it will default to the latest build. So that's a keeper resource, bit of YAML. Let's go to the next one. This is a very simple ClickHouse cluster resource. So again, very simple, doesn't even include the image that we're going to use. It's going to pull the latest ClickHouse build. It's going to have 2 replicas. We can see that down below, and it's going to have 10 gigs of storage. For development purposes, for example, when you're doing this on a laptop or on a development host, this is all you need to get both Keeper and ClickHouse set up and talking to each other. Let's look at what's actually happening underneath. So we have these these different types of resources. We sometimes call the ClickHouse installation a Chi resource and the ClickHouse Keeper a CHK. We can use those abbreviations in Kubernetes. It's less to type when we're manipulating them. In each case, what they do is when they lay out the resources in Kubernetes to create this, they're first of all going to create a model or a resource that's called a stateful set. This is a type of resource in Kubernetes that knows how to manage storage and comes up with a predetermined name. These are both very useful for databases because 1, we need to be able to find them. 2, they need to be able to find their storage if they restart or if they get rescheduled to another host. The storage itself is represented as what's called a persistent volume claim. That is a request to Kubernetes to allocate storage. When that storage is allocated, it becomes represented as a persistent volume. That's a real patch of storage somewhere out in the cloud or on local NVMe SSD that you can write to. Under the cover, in the end, these are just processes running on hosts. But the Kubernetes modeling with these resources allows us to tell Kubernetes, this is what we'd like to see, and then Kubernetes takes care of representing it. Let's go ahead to the next slide. So what I'd like to do now is kind of dig into what's going on behind the scenes and specifically some of the things that we can do as we set up these CHI and CHK resources. So let's go to the first slide. First of all, installing the Altinity Operator. This is a very simple operation that with a typical network connection will take 10 seconds or less. The Altinity Operator is a container like everything else that does any work in Kubernetes. And this command here, if you just type this in and press enter, and you are pointing to a Kubernetes cluster, it will pull down this piece of YAML that contains the full definition of the operator and all the things that it needs to operate. So, and those include a number of things. For example, config maps. These are various types of tables, sort of tabular information that supplies parameters and other types of information that the operator needs to function. We set up a service account with appropriate roles so that we have the ability to manipulate things within the namespace or namespaces that we're operating. A really important part of operators is they have what's called a custom resource definition. And in fact, the Altinity Operator has 4. They are the CHK resources. They are they are the CHI resources and then a couple different kinds of templates, which Alexander will talk about. Finally, there's the operator itself, as well as an additional sidecar service that exports metrics. So all of this stuff comes down and just gets, if you run that command, and just gets pushed into the kube system namespace. So here's what we're going to do now is dig in a little bit in the CHI resource and show you some of the key elements that you would want to know even in a development environment. They are talking to Zookeeper, the layout of your cluster, like your shards and replicas, how you define the container you want, that's your pod template, and then how you define storage, that's your volume claim template. Let's jump into these. So so here we have cluster layouts and locating and finding keeper. This is usually the first section in any of these. There's an A missing. It should be API version. And then we have the ClickHouse installation. That's our resource. And then just some very straightforward information. Number of replicas, number of shards. This is all you need to do to set up replicas. And the ClickHouse operator is pretty smart about them. If you put schema in them, you use on cluster commands that will show some examples of that. If you add replicas later on, the operator will take care of automatically transferring your schema to new replicas or even new shards. And then there's the Zookeeper location, which is shown below. Let's keep going. There's an additional section which is useful to know about. You don't always have to use it, but it's server settings and configuration files. If you run ClickHouse directly on, say, bare metal or up in the cloud, you know that you often have to set up configuration files or do things like change the number of maximum concurrent queries. These can be added to the definition and will be automatically set up in the configuration when it lands on a host, when that container lands on a host and starts. Pod definitions. So this is in the development form that we're showing here. This is very, very simple. All that you have to do is you have this spec section. You list your containers. You can actually have multiple containers in there. We're just going to be using one for now. Give it a name and say what image you want. We can the Altinity operator runs with basically any ClickHouse build you can find. So we do our own Altinity stable builds. There are, of course, ClickHouse official builds. There's Altinity Project Antalya. All you have to do is name the image and we'll get it for you. Moreover, the ClickHouse operator or the Altinity operator is very agnostic about server versions. I think the oldest version that we have running in production right now is 21.11, which is getting pretty long in the tooth. They should probably upgrade, but basically whatever version you're comfortable with, you can just pop it into the operator and it should run just fine. And then finally, the storage definitions. So this is, again, very straightforward. The volume claim template, two settings that are useful to know here. First of all, how much storage you want. And by the way, you do need to include this. If you don't include this section in the definition, you will be running on ephemeral storage, which means it'll evaporate if your container storage gets deleted. There's another important little thing here, this reclaim policy. What that says is if we drop the cluster, don't delete the storage allocations out on Kubernetes, specifically the volume claim. What that does is if you get fat fingers and you accidentally delete something, like blow a shard away or just blow the whole cluster away, the PVCs will stay up. And when you realize the error of your ways, you can just reinstall and it will find the storage again and keep running. It's a really important trigger lock to keep you from getting into trouble. We're not going to talk about the ClickHouse Keeper installation very much, other than to note that it is, because it's basically it is the same ClickHouse binary that is implementing this as implements the ClickHouse servers. So as a result, the CHK installation, the resource is very similar, and you have things like replicas, number of keepers. You have a pod template and volume claim template, so you can set your pod, your container image as well as your storage. So it's pretty straightforward. All right. So let's get into deployment tips. So all of the stuff I've shown you so far, that's all the knowledge you would have to begin developing and playing around with ClickHouse on your laptop or on a development machine somewhere. All right. So as you're thinking about actually turning this into a production application, there's a number of things you need to do. First, a really important thing is for most people is they don't want to run Kubernetes themselves. If you're running in the cloud, this is actually one of the best bargains around. Virtually every cloud provider has and some non-cloud providers have their own managed Kubernetes, and you just use that. So, for example, EKS, GKE, AKS, those are on the big three. They cost about $70, something on the order of $70 to $100 a month to run, so which is practically free, and they take care of all the grunt work of keeping Kubernetes up to date, making sure that security patches are delivered, making sure that that things are backed up, giving you a simple way or giving you like an automated way to bring clusters up and put them away. This is something you should absolutely use, and unless you're very, very deep in Kubernetes, in which case you may want to manage it yourself. So that's the first thing. Just pick one. I personally use EKS because I do a lot of stuff on Oz, but any of these will do the job. The second thing is you want to learn how to wire this up, and there's two really key things that you have to handle. Because what Kubernetes does is Kubernetes will schedule things, and it knows when it can't schedule something and can actually, for example, needs to go and allocate more VMs so that it has additional capacity. So that's done through something called Cluster Autoscaler, at least on Amazon. So we can use Terraform to set this up, but basically what that will do will configure the underlying cloud infrastructure and configure Kubernetes so that it is correctly wired through with the correct authorizations, so that when it needs to allocate a pod or delete a pod, it can take that and basically spin up or spin down VMs at will. The same thing applies for storage. Storage is defined in something called a storage class. That's a really key resource in Kubernetes, and your persistent volume claim refers to a storage class. You have a storage provisioner, or which will read the persistent volume claims and allocate matching amounts of storage. So this can all be automated, but it's a key thing that somebody in the organization needs to understand how it works. Some key things that we've found, which are really important for running ClickHouse in production, is first of all, you want to allocate a separate host for each ClickHouse. So and here are the settings in the operator that allow you to do this. First of all, let's say what kind of image type do we want. This is an M7G. That's a Graviton, great on Amazon, high performance, lower cost than equivalent Intel, not necessarily AMD, but pick the image you want, and what this will say is this guy, when it comes up, needs to have this image and needs to be running out. Second thing, let's skip down to the bottom. Pod distribution. What this is saying is it's kind of like the Highlander principle. There can only be one. So it's using anti-affinity, which is a setting that's available inside Kubernetes that we build on top of to push these CHI resources onto different VMs. So that's really important because we don't want two VMs sharing the same host. That would be bad. They would be competing for resources. It would also be bad if that host went down. Third thing, tolerations. This allows us to say that the hosts that we're going to be running on can only, the hosts that we're going to be running on have to have these taints, and basically, the hosts have the taints. These tolerations say, hey, we can be scheduled on these hosts. So it allows you to have pools of resources that are only for ClickHouse servers and not necessarily for, say, ClickHouse Keeper or other applications. So these are all settings that are very easy to do in the operator. So next slide. All right, storage classes. I love storage classes because they're actually really easy to understand. They've improved considerably over the last few years. This is an example of the storage class for GP3, which is the current most advanced form of elastic block storage on Amazon. It includes encryption. Um, yes, there you go. You see the parameters. It includes things like we can set the file type. Really important features here. We can set the disk throughput, including and IOPS. We can also allow volume expansion to be done online. These actually can be changed online. Let's go to the next slide. So you can go ahead and actually change storage on live systems. It's pretty simple to go from 50 to 100 gigs. You just have to go patch the volume claim template and it will allocate it. It's a little bit trickier to do things like scale up the disk throughput, but that is also can be done. We wrote a blog article on the way that we do it in Altinity.cloud. We have a special controller that does that. But this is something you want to get correctly wired. It is one of the most common ways that people upgrade systems, either to increase storage. That's probably the number one way the systems upscale, and then to change the disk performance, in response to new conditions. Backup. So since we're talking about storage, that might make you think, well, what if I lost it? Which is a good thing to think about. Backup is a many splendored thing. We run the Altinity backup for ClickHouse. It's in a project called ClickHouse Backup out on our GitHub. This is how it works, and we're not going to show you the details because they tend to be pretty complicated. But um, we we have the ClickHouse installation, and then what we use is what's called a sidecar, which means instead of having one container running in the pod, we actually have two. The first one, of course, is your ClickHouse server. The second one is a container that's running the ClickHouse backup binary. And because that's running in the same pod, it's in the same process space. It can see the storage, which is necessary because it needs to actually be able to see the storage and play around with hard links to be able to do backups. And then it can write to what says persistent volume, but should not be a persistent volume, but instead be object storage. We'll correct that in the final slide version. So what you'll do is you'll allocate a bucket and make sure that the IAM is correctly wired so that you can write to it and read from it, and that's how you store your backups as well as restore them on demand. You can also use the internal backup commands. Those don't require an extra container to be installed. That's another option. And as Alexander will discuss, we have roadmap activity that we're going to be roadmap work that will improve this still further over time. I think that's it. Alexander, back to you as we get on to ideas for building data platforms.
Yeah, thank you, Robert. And let me introduce you to some more advanced features of Operator that allow you to build very complex production systems and data platforms. First is templating, and we already talked about storage templates and pod templates, which are actually standard Kubernetes abstractions. We haven't invented them. They existed for a long time. But what we added in Operator, which doesn't exist in Kubernetes by itself, are two things: service templates and ClickHouse installation templates. Service templates help you to define network configuration, and ClickHouse installation templates help you to define anything in the spec and do a lot of things that looks like a magic. So let's start with service templates because it's pretty simple. In Operator, we support several different types of services that can be deployed. It starts with just a service template, which is a load balancer for ClickHouse installation. So if you have multiple shards and replicas, you may use this service, and it will randomly connect to any of your ClickHouse nodes. There are also service templates, and you may have multiple service templates like that. For example, one for internal load balancer, another one for external load balancer if you want to. There is also what we call replica service template, and the name is a bit confusing. In fact, this is a service template for every ClickHouse node, and using that, you may have a service that allows you to connect to a particular ClickHouse node from Kubernetes. Sometimes you do need it, and actually quite often if you want to connect to a specific node. And finally, there is a cluster service template that allows you to connect to a specific cluster. We haven't mentioned that, but one ClickHouse installation may actually work as an enclosure for multiple ClickHouse clusters. It's not very easy way to manage that kind of stack, but we still do have a support for that. And here's an example of service template, which is very simple. You have a name, you have generate name, and the generate name allow you to use macros, and therefore you don't need to hardwire the name. You can just specify that I want my service to be named like service dash and the name of my ClickHouse installation, and port definitions which I exposed. Of course, those ports needs to be open on a pod first, but in order to connect from Kubernetes, you still need them to be as a service as well. And just to finish on service templates, if you work in some cloud provider Kubernetes, you will use service template in order to specify cloud provider specific load balancer settings. For example, if it is AWS, you will have to put annotations in service template that would instruct Kubernetes how to expose your service if you want to, and what kind of load balancer to use, some specific security settings, and that kind of stuff. Therefore, for production operation, this is a must. Next is ClickHouse installation templates. For that, we have a separate Kubernetes resource, which we call a cheat for simplicity. And structure-wise, it is identical to ClickHouse installation. It has pretty much the same structure, same objects that you can define, and I will show you why. The purpose of ClickHouse installation template is that you can define parts of your configuration. For example, you can define what kind of pod template to use, and then this is one of typical use case, and you can use it in order to provide defaults or in order to have some shared configuration between multiple ClickHouse installations in your environment. Or you can use it in order to override behavior. So say you have ClickHouse installation which you deploy with some automation, and then you want to inject some specific behavior by other automation. We use it quite often in Altinity Cloud. This is a very powerful feature. Here's a very simple example. I define here ClickHouse installation on the left side, and add a special reference use templates. This is an array, so I can use multiple templates, and in this example, I use ClickHouse-version template. And this ClickHouse-version template, it is described on the right side. What it does, it defines for me what kind of ClickHouse version to use in any user of this template. So on my left side, in my ClickHouse installation, I don't have to specify the version anymore. I will just use the one which is provided by template. And if, for example, the new version is coming, I can change the template. I don't need to change the installation, which is really convenient. Here is a more kind of frightening example, and sorry if you cannot see it clearly, but this is an installation template that opens up PostgreSQL port in ClickHouse, and it has to do multiple things in order to open a port. It has to open a port on a container first. This is on the very bottom. Then it has to define a service, and we define a special service template for Postgres connection. Finally, it needs to define or open a Postgres port in ClickHouse itself. There is a special setting for that. And on top of that, we specify that this template only applies to a single ClickHouse cluster, but applies automatically. So for that ClickHouse cluster, we even don't need to use templates. This policy auto that you can see, this is an instruction to automatically apply this template to all ClickHouse installations that match the selector. This is kind of an inversion of control, but it allows you to not to touch anything in your ClickHouse installation, but still deploy some behavior or some changes to your running system. This is very, very powerful mechanism, and I don't know if any other ClickHouse or any other operator for databases has something similar like that. Next important thing is rescaling. And if you run in production, you usually start small, but then you tend to grow bigger. You may add replicas, for example, and ClickHouse and our operator, it does it very smartly with no downtime and no service interruption. So first, it creates new pods and storage, as you can expect. And then it creates schema on new replicas automatically. So if you have tables on your cluster, those will be automatically created on new replicas. And finally, it will wait for replication to catch up. So if you have a big cluster with hundreds of terabytes of data, you cannot just start using the new replica immediately. It will be lagging behind, and your queries may get incorrect results. Therefore, operator will wait for replication to catch up before including this new replica to a load balancer and making it available for queries. This is one more reason to use a load balancer, because if you connect to replica directly, you don't have this control of replication. So this adding a replica doesn't require any restarts. It can be done on a running cluster automatically, transparently. Same for sharding. So if you want to add more shards, you can do the same. Just increase the counter in your ClickHouse installation, and the operator will take care of adding pods, adding storage, creating schema on shards, waiting for replication to catch up if you have replicas for those shards as well, and so on. What it doesn't do any resharding. So if you add new shards, then those new shards are empty. And this is kind of conscious decision of ClickHouse from the very beginning, because the data sizes are typically big and resharding is typically very, very expensive. So if you add more shards, you just wait for time to come when the new data will be distributed across many shards. Scaling down, same. So if you had 3 replicas, you can go to 2 replicas, and the operator will take care about doing this change without service interruption. It removes nodes from load balancer, it removes resources, and finally it even cleans data in the keeper because ClickHouse doesn't do it automatically when you remove a replica. Rescaling storage, Robert already touched that a little bit. You can add more storage in your ClickHouse installation. And in fact, operator has 2 ways to manage storage. There is a traditional way when you define a volume claim template as a part of stateful set on Kubernetes. And if you change the volume claim template in stateful set, you will have to reprovision the pod, recreate a stateful set. That requires a downtime. This is why we implemented a different way to manage storage that is called provisioner operator. In this case, operator creates PVCs directly without using stateful set logic anymore. And because of that, operator can modify the storage directly with no downtime if storage allows volume expansion. This is very powerful. Unfortunately, by default, the stateful set provisioner is used because this is a standard, and we cannot change default easily without affecting running ClickHouse installations, and we don't want to do it. But those are totally interchangeable. We had to skip one slide here because it is very big, but you can also add multiple volumes. Operator supports multiple volumes, but you will have to do a lot of wiring in pods and in ClickHouse configuration manually because there are a lot of nuances that operator just don't automate or don't provide a syntactic sugar for you. But this is all available if you know what to do in Kubernetes. Next important thing that every ClickHouse user in production will have to use is upgrades and configuration management. How you upgrade your ClickHouse, how you change configuration. And the image change, of course, if you change the version, it requires a restart of a pod, which is pretty expected. If you change something in pod template or storage template, volume claim template, then operator will recreate a stateful set because in many cases those changes cannot be done on existing objects. This is a limitation of Kubernetes. But when stateful set is recreating, it is performed in a random fashion, and I will show you in a second. And finally, what you always have to do is to make some changes to ClickHouse itself. Change some server settings, add some configuration snippets for ClickHouse itself. And depending on the change that you're doing, it may be very fast restart using system shutdown, which doesn't require any pod recreation. That's why it's very fast. Or it may be done with no restart at all if this configuration change can be taken by ClickHouse server automatically without any restart. Speaking about restart, we invested a lot of our effort to make sure that restarts are as smooth as possible and don't affect operation of your application. And it is performed in multiple steps, starting from removing a node from a load balancer. Then the node is removed from remote servers. This is internal ClickHouse cluster configuration. It makes sure that your distributed queries that may hit a different node, but a distributed query may be executed on many nodes. And if we remove this from remote servers, then distributed queries will also skip this node. Finally, operator waits for running queries to finish. If you have some queries, we want to make sure that your client don't get interrupted. And only after that, it tries to restart or recreates the port or do anything for the maintenance. Once the operation is completed, it performs everything in the back order. It adds node backs to remote servers, and then it adds node back to load balancer servers. On a big installations, and we have examples of ClickHouse installations with hundreds of shards. Multiple shards can be processed in parallel just to speed things up. Because you can imagine if you need to upgrade to 100 or 300 nodes one by one, it will take quite a lot of time, 3-5 minutes per node. But you may do multiple shards in parallel without service interruption. And the amount of this parallelism can be configured. Couple of notes about configuration. We already showed a few examples. I want to highlight that different part of configurations, they somewhat deployed differently. For example, config.d files and user.d files, these are common for all ClickHouse installations. So if you make any change, it is propagated to all the nodes. Conf.d, it looks like the same, but internally it is mapped separately for every node. And that allows us to do customization per replica. For example, on the right side, I show that I can provide different settings for different replicas in order to specify availability zones for ClickHouse, not for deployment, but for ClickHouse to know in which availability zone it is running. This is a rare use case, but sometimes you need to provide a replica-specific configuration, and you can do it with the settings, but internally it is using this conf.d mapping. Maintenance. Of course, if you're running operator with your cluster, you need to do some maintenance tasks. And we have support for many of them, starting from stopping your cluster. If you have a development system, you don't want to run it 100% of the time, you can just stop it, and the operator will scale down all stateful sets to 0. So pods are deleted, but all the storage and everything else is there. And as soon as you need to start it back, you just remove this stop attribute or set it stop null, and your cluster is up again with the same storage and with the same data. Restart attribute. Sometimes you may want to restart your cluster because something goes wrong, and you can do it specifying the restart task. Operator itself, it cannot perform tasks. It can only process Kubernetes resources. Therefore, if we want to emulate tasks, we have to do some uh, tweaks. And in this case, we can use the restart attribute, and we can pair it with task ID. Task ID is a way to specify that I want to execute this task, and ClickHouse operator takes track of executed tasks. So one task is executed only once. So if you want a new task, you need to change the task ID. Finally, there are two attributes to do some troubleshooting. There is a suspend attribute that stops reconciliation. So any changes that you do to your ClickHouse installation, when it is suspended, they are not propagated to Kubernetes resources. So you may do some multiple changes maybe, and then turn on operator and deploy them. And troubleshoot mode, it is important if your ClickHouse, for example, in crash loop, you don't understand why it is failing, and you want to look closer, you can turn on troubleshoot mode, and operator will leave container running after ClickHouse process is terminated. So you can still exec to the pod, check the logs, probably try to start the process again, see why it's crashing, and therefore figure out what was wrong. There are a lot of knobs to reconfigure to tell operator how to process reconciliation loop. And I don't want to explain any of them, just mention that you can configure concurrency, you can configure inclusion and exclusion rules, you can configure which probes to check when things are deployed, you can configure timeouts, different timeouts, and a lot of settings to make sure that you can tune your operation and make it as safe as possible. Many users require different things, and the operator provides all the way you can customize it. The configuration, and there is another kind that I just showed, ClickHouse operator configuration. It's a new kind, and in operator documentation there is an example which contains all possible parameters with comments, so you can use it as a description of what can be changed and why, if you need to. And the last thing, which is very, very important for production, is monitoring. You need to know how your ClickHouse is running. And the operator, of course, provides this information using a special sidecar to operator itself. It's called metrics exporter. It exposes Prometheus endpoint to 8888 port and collects a lot of data from ClickHouse, including metrics, event, table sizes, and much more. ClickHouse itself has its own Prometheus endpoint, which has been developed later, not so long ago, and it actually provides less information than operator. Therefore, we kind of still stick with our approach when operator queries ClickHouse in order to gather the monitoring data and then exports this data to the endpoint. It's worth mentioning that many users or some users, they want to define their own metrics, and they can do it using custom metrics table or any other table. Custom metrics is just a default name. This table should match system metrics ClickHouse table by structure, so same columns, same table types, and but you can define different things, maybe application-specific metrics. Usually, it is done via some sort of a view, SQL view, that extracts different information from your application data and exposes them to the same Prometheus endpoint. For standard ClickHouse monitoring, we have dashboards. That includes dashboards for ClickHouse metrics, for query analysis, for Zookeeper, Keeper, and maybe a few others. Here is an example of one of dashboards. You see queries that are running right now, how many queries started per second. You can see same for inserts running, inserts started per second, how many rows inserted per second. You see this is pretty heavy loaded system, 3 million rows per second, and so on and so forth. This dashboard, it maybe have a couple of dozen of different charts, and they are created by our support engineers to monitor ClickHouse. Sorry for this deep dive. I think it was useful, and it uh, captures a few things that you may need to use in your ClickHouse and Kubernetes. Next thing to discuss today is how you automate your deployment, and Robert can take it from here.
Yeah, thanks. So, yeah, let's go to the next slide. So there's just a bunch of ways to automate deployment, and I'm just listing four of them here. Um, so some folks are still using Ansible. A lot of Terraform use. Helm is really popular. I'm not going to cover it, but plain old manifests with a hairy bash script are also a really great way. Uh, for lots of custom deployments, we still see this. What I would like to focus on is Terraform and Helm as the most popular ways to deploy. Let's go to the next slide. So the cool thing about Terraform is that it can deploy both your cloud infrastructure and the stuff that runs inside Kubernetes. It is, of all the ways that you can deploy, it is the most versatile. You may, get tired of watching it because it's kind of like watching paint dry to run. You have to manage the state carefully, but it is if you're going to pick a single API, this is the one to use. There's a couple of Terraform modules that we have that will help with this. If you're on Amazon, we built with the help of our friends at Amazon starting a year and a half ago. We have the Altinity EKS Terraform module. This QR code is will get you to the project. There's also a link that you'll see in the slides. I use that actually to constantly when I'm working on open source developments. We don't, unfortunately, have this extended out to GKE and Azure yet, but it's definitely good for Oz. If you are running this, want broader platform coverage, or you want something that does everything soup to nuts, there's Altinity.cloud. So this is our cloud platform for ClickHouse. It has a great Terraform provider, which will set up what we call a bring your own cloud model, where ClickHouse is going to run inside your environment using your data, using a Kubernetes cluster that we set up for you. And there's a BYOC Terraform module that sets that up. It's pretty powerful. And then you're able to manage it, not just on the command line, but you can use the Altinity.cloud UI. That's a very powerful way to manage. Second thing, people love Helm, and so we do have Helm charts. Important one that is very convenient if you're just setting up sometimes when you're setting up the operator, you can use a Helm chart to set the operator up the first time. The second section shows how to do this. So you just add our repo, update, and then go ahead and install the operator. We also have a sample application for ClickHouse. What I like about Helm is that for managing the manifests for ClickHouse clusters, it's a pretty convenient way to do it. A lot of people use Helm, and then they'll couple it with something like Argo CD, which is really good at running Helm charts at the right time. One thing I want to point out on Helm is I think many people are aware of this, but if you're not, Helm does not deal with operators very well. And the problem is that it cannot upgrade an operator because it can't properly update the CRDs, these custom resource definitions, because what they do is they change the behavior of the API of the thing that it's trying to upgrade. And Helm just kind of throws up its hands. So there's a special, if you're going to use Helm for the operator, when you do an upgrade, you actually have to load the new CRDs manually and then run Helm upgrade, and then it's fine. But just a tip for the unwary. And Sasha, you're going to talk about differences between there's two operators out there now, so we're going to talk a little bit about the differences between them.
Yes. For the years, we were the only operator for ClickHouse, and actually, uh, Altinity ClickHouse Operator is the most popular operator for databases after Postgres on GitHub. So we collect statistics for that. It has 2,500 stars right now, which is pretty significant for operator. And this is because we introduced it pretty long ago in 2019, and we were operating it for production since then. ClickHouse Incorporated, they are they started to develop their own operator last year, and in January 2026 they introduced what they call official ClickHouse operator for Kubernetes. And of course we were curious what it is about, and a lot of our users are also asking. It's pretty hard for us to be unbiased, of course, but it's evident that ClickHousing, they're very early in their um, game or road with operator. Altinity Operator is used in production by multiple companies and operating thousands of clusters. I'm not talking about Altinity Cloud solely, but eBay, OpenAI are big logos that use Operator and many others. For ClickHousing, it's not clear if it is used in production or not. It is certain that this is not an operator they use in their cloud, which is quite strange and weird, because for us it was very good that we are kind of operating with our operator, and that drives our development. We were users of that, and very heavy users. Therefore, Altinity Operator is certified for a number of Kubernetes platforms, and by certified I mean we have production deployments on those. And these are not just big three, but also DigitalOcean, Linode, OpenShift, and some exotic ones like Oracle Cloud Kubernetes, for example. Altinity Operator supports any ClickHouse distribution, any ClickHouse build. ClickHousing, I guess they tend to use only official builds because they want to be 100% official. I have shown you a bit of configuration management, and actually it's just a tip of an iceberg. There are so many things that you can do to customize your ClickHouse deployment. As far as we see right now, ClickHouse Inc. Operator, they don't invest in this. They want to make it as simple as possible, fire and forget, which is usually not true for ClickHouse. We support any database engine, because when we started, the only database engine was Ordinary. Now there is Atomic, there is Replicated, and many others. Everything can be used with Altinity Kubernetes Operator or ClickHousing. They force users to use replicated database engine, which is great and convenient, but this is a limitation, and it can only be used with a keeper or Zookeeper. Speaking of that, we support Zookeeper and Keeper, pretty agnostic about what you're using. ClickHousing, they integrated Keeper support in Operator. By the way, Keeper is production ready for several years, but it's still slower than Zookeeper on high rate transaction. This is ridiculous. We recently retested it and was very surprised to see that. And we're now preparing a pull request with some changes to ClickHouse in order to improve concurrency for Keeper. Finally, backup and restore. We can do it with a sidecar, and by a sidecar, I mean it's full backup management. It's not just backing up your data and restoring it once. You can do the full support. You can do table level backup and restore. You can use a lot of different media to store your backup, and so on and so forth. ClickHouse ClickHouse Sync Operator, they have it on a roadmap for this year. We'll see what they came with. The good thing that both operators are Apache 2.0, so you can use it if you want to. And finally, to wrap up our presentation and switch to questions, if we have some time, here are some major new features for Altinity Operator in this year. We typically are not very good in communicating roadmap, and we use this opportunity to tell you about a few things that are coming this year. First, we will add some post, start, and press stop SQL hooks. We need it in order to support Antalya better, our project Antalya. For example, when swarm nodes are stopped down, we want to do it gracefully, and that requires some SQL injection on this shutdown sequence, and we can plan to add special SQL hooks for that. Also, we started to productize the keeper support, and better integration of CHI and CHK is coming later this year. Also, an interesting development that we consider is how to add new replicas with smaller downtime and faster. And it can potentially done via persistent volume snapshots. The snapshot itself, of course, it takes time to make, but after you have a snapshot, you can spin up a new replica from this snapshot and only catch up replication lag for the smaller amount of time between the snapshot has been taken and your actual and when you recreated the volume from this snapshot. Some of our users in the wild they tried this approach and find it very interesting. And finally, we have some pressure from the users to make operator extendable using some sort of plugins. And we can imagine that first plugin to come is backup. So you can plug backup as a plugin and configure it using some manifests. Another example of plugin is resharding plugin, and maybe some others, which will do some heavy lifting, heavy job, not an operator job, but some extra logic outside of operator, but that can be controlled by operator still. That's it from what we wanted to share you and talk to you about. And Robert, do we have time for questions?
We do. We can go till 10 after. So, by the way, thank you everybody for listening. We realized as we got into this that there's just such a huge amount of stuff in there. We've been working on this pretty hard for yeah, since 2019. So it's coming up. It's over 7 years. But actually, it's about 7.5 years since the development started. By the way, this the mothership is the Altinity Operator GitHub. That's the QR code that's shown there on the left. Go out there. That's the place to find information. If you have other questions, please do contact us. Join our Slack. You can ask us interactively. If you have specific issues or feature requests, please go ahead and send. Go ahead and file issues, or better still, do PRs. We have had lots of community contributions on this. Yeah, with that, let's go to questions. I want to just we had a question from Paul Julien who had to drop, but he said, I've seen recently ClickHouse is working on their own operator for ClickHouse on Kubernetes. What's the path moving forward? We've shown, we showed that, and he said he was just trying to understand where things are heading. So we are not we are 100% committed to the operator. As you saw from this presentation, our whole business depends on it, as do hundreds of companies, or if not thousands. I mean, we don't even know who's using this thing. Because for a lot of people, it just works and they never say anything. But in our own, we have around 300 customers at Altinity right now, and a substantial chunk, like at least 80% of them, are using the operator in some form or another. So yeah, we're going to keep pushing as hard as we can on this. And as Sasha says, we will, keeping an eye on what's going on with the, with the upstream ClickHouse operator. It'll develop over time. I will say that I think it's pretty hard to, as Sasha pointed out, having this underneath production systems that you're supporting, like our own cloud, is a real forcing function to get the quality right. There are some very hard problems, like rolling upgrade is a very, very hard problem, particularly at scale. So, Sasha, there's one here in the production setup about it's in the Q&A. It's about NVMe, and and can you see this one? It's using EKS. I think this is one where they're asking about auto scaling.
Yeah, this is a hard one. So as you know, NVMe are local disks and they're not network disks, so you cannot easily scale compute. And this is one of the main reasons we don't use them in the cloud, even though we did experiments with NVMe disks 5 years ago when we started operator development. Having said that, we now have a use case for NVMe. This is high performance cache for Parquet data for Project Antalya, and we will develop some support and some expertise on that. The biggest problem is how to mount them properly into your Kubernetes pod because um, it is it is tricky. No, normal Kubernetes provisioners don't deal with local disks good enough because they kind of depend to the node, not to the cluster itself. And we're still looking for the best way to support it in our cloud. And as we know how to operate it by themselves, we will definitely share it with community.
Yeah, thank you. More questions here. Let's see. Finding documentation about custom metrics. You can go to that was another question. You can go to the ClickHouse operator project on our GitHub. Another thing you can do now is just pull the code, just go ahead and clone the code and turn Claude code loose on it and ask it any question you want. It'll read the code and it gives you pretty good answers. We're starting to use that ourselves to remind ourselves what the code does. Here's a question. Does the ClickHouse Helm chart support Keta so that I can use Keta for the scale up? The answer is no, and we're very interested in Keta, but we don't use it currently. Alexander, do you have any expansion on that? Uh, Possible support for Keta in the future or thoughts on that?
Yeah, we were thinking about this, but unlike small LTP databases, ClickHouse is typically a heavy database. If you have a lot of data, then you cannot easily use automatic scaling mechanisms uh, to add more resources. So therefore, we were a bit skeptical about that. But things may change, and as we started to move towards storing more data into object storage, we may start using Keda for swarms, for example. Swarms are stateless compute servers, ClickHouse servers that only query Parquet data or query data from object storage, and therefore they don't have any state and can be scaled up and down pretty dynamically. So for this use case, Keda may be a good solution, and thank you for reminding us.
Yeah, and I think that's a really important point. So we have not said anything or said very little about Project Antalya in this because we're talking about the operator, and as you can see, there's enough to talk about here already. But the big the big gap is not in the operator, it's in ClickHouse itself. So ClickHouse, open source ClickHouse does not have built-in separation of storage and compute. That's exactly what we're putting in Project Antalya. So two major features. One is these swarm clusters, which allow you to scale up and scale down resources for query on any object like, so Parquet data on object storage, including iceberg tables. Second thing is hybrid tables, which allow you to do tiered storage uh, out to data lakes. And so in both of these cases, you now have the ability to these swarms to scale the compute up and down. So there's real the normal ClickHouse, because you have to replicate the storage when you build new replicas, it's incredibly slow. It's a heavyweight operation. There's almost no point in automating it. But once you have swarm clusters, as Alexander says, it's a completely different picture. And we're pretty excited about being able to use that. And not just using, not just scaling it up and down, but also using things like spot instances much more widely so that we can reduce compute. I think we're at 9:10. Alexander, any final words you want to say on, based on the conversation so far, things you want to add before we close?
Yeah, one final word. So, Operator is open source project, and we have more than 100 contributors. So, if you have something to contribute, so you're totally welcome. We accept contributions.
And we love them. And thank you all so much for attending. We hope this was useful. Feel free to ping either of us directly. You can get us on LinkedIn. I think I talked to many of you. Thank you so much for the questions, and join our Slack and try the operator out and let us know what you think. So thanks again. Have a wonderful day, and we hope to talk to you soon.